Hi there, I'm back with more fractions. Okay, so we're still doing division. So 4/5 divided by 2/3. So division, let's figure out what the question is asking, whoops, actually asking you to do. What are we trying to solve? So what we're trying to solve right over here is how many times do 2/3 go into 4/5? So that's the question. How many times do 2/3 go into 4/5? So the first step with division, we are going to represent both fractions in an area model. So this is first my 4/5, and I am coloring in 4 pieces out of that out of 5. Okay, and the other one, 2/3, because I dissected the first area model, first whole from top to bottom. I'm going to dissect the second fraction from side to side. So now I want this to be like that, 2/3. Okay, so what are we going to do now? What we're going to do now is, wait, oops, forgot to color that. Okay, so this is my 4/5. This is my 2/3. You can't see. Okay, so now we are going to find our common denominator. So we will superimpose these two area models on top of each other. So I am going to dissect my first whole into 3 equal parts, and I'm going to dissect my second area model, second whole, from top to bottom. I am laughing because I can hear my dog rolling on the rug and making strange noises. Okay, so now we can figure out an equivalent fraction for both fractions. So for this one, I multiplied both the denominator and the numerator by 3. So I know that my equivalent fraction is 12/50ths. And for this one, I multiplied both the numerator and the denominator by 5. So I know that my equivalent fraction for that one is 10/15, right? And I know that my unit fraction, every little piece, that's all equal pieces, that's unit fraction is 1/15. There you are. Okay, so if I count this part, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Right? Of course they are. Of course they are, because it's 10/15. I know that there are 12 right over here. So if I were to rewrite this question, now the question is how many times does 10 go into 12? That's a new question. How many times does 10 go into 12? So let me count. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. It goes in at least one time, right? And I have 2 of these little pieces left. So this is the interesting and very cool part. I said it goes in at least one time, right? So that means when I have 10 out of 10 pieces, that's my new whole. So when I'm trying to figure out, okay, it goes in at least, okay, 10 goes into 12 at least once, and then 2 left. but 2 over what, right? 2 over what? So this is what's going to help you, because I know that when I have 10 out of 10 pieces, that's my new whole. So 10 over 10, that's my new whole. That means this, I have 2 over 10. So I have the answer to the question for this question, answer to this question is 1 and 2, 10. And I can simplify this part by dividing both the numerator and the denominator by 2. So I know that this is 1 and 1 fifths. That's the answer. Okay, now we're going to figure out, I'm sure you've all heard someone say, you know what, whenever you see a division, you can just turn this sign into a multiplication sign. You can flip the numerator and the denominator of the second fraction and turn it into that. So now the calculation is going to be 4 over 5 multiplied by 3 over 2, and somehow you magically get an answer to a division. How does that work? Why? Why and how? Okay, so I'm going to show you why and how. Okay, so here, how many times does 10 go into 12? The calculation that we did here was 12 divided by 10. We just forgot, you know what? We have 12 right over here. We have 10 over here. What we wanted to figure out is how many times does 10 go into 12? We could forget about the common denominator for now, and we wanted to figure out how many times does 10 go into 12, right? 12 divided by 10. So how did we get the 12? How did we get the 10? So for 12, we got this 12 from here. 4 multiplied by 3. And how did we get the 10? Right over here. That was part of the process of finding an equivalent fraction. 2 multiplied by 5. And if I rewrite this division, it looks like that. And of course I can calculate it, and I'm going to tell you that it's 12 over 10. But that part is not the important part. That part, that part is not the important part. So this part is the important part. Okay, so 4 multiplied by 3 over 2 multiplied by 5. And let's take a look right over here. If I were to rewrite this as well, it will be 4 multiplied by 3 and 5 over 5 multiplied by 2. Do you see that you're doing the same calculation? That's how it works. But what you are doing is you are dividing 12 by 10. And how did we get the 12? That was part of the process of finding an equivalent fraction, right? So this process, knowing what you are actually trying to figure out and how you're doing it, an area model allows you to see that really visually, and that part is the important part. Not plugging into formulas, but knowing why that part works. Okay, so I'll be back with more fractions and more divisions later on. Thank you.